Hello students, till so far it is known by ourselves that how can we find the equation of curve for a given statistical distribution. Okay, that means we can fit a curve for a given data, for a given statistical data, that's for a given distribution, but it is not essential that we can obtain the equation of the desired curve in the form of a straight line or in the form of a parabola, etc. Sometimes we have to find the equation other than straight line, other than parabola, other than cubic also. So in that type of situation, how can we find the equation of curve? That we have to learn and that we are going to discuss here. Okay, so we start here. Curve fitting of some more general curves. Okay, that's why its topic is here today. So what's the question we have is, for example, I'm taking a question, an example, and then we discuss it. Then how can you find its equation, this type of equation? Okay, see this question. Okay, that is using the method of least square, fit the curve y is equal to ax square plus b by x to the following data. This, okay, here the values of x and y are given, and what we have to find, we are required to find the equation of that format, y is equal to ax square plus b by x. So see carefully, this is not the equation of a straight line and neither the equation of a parabola and not the equation of a cubic, etc. Okay, so how can you find this type of equation for this given distribution? Okay, that is we have to do in this video. Okay, okay, so first of all, what we do, first of all, we take the desired equation, that is y is equal to ax square plus bx, and then we multiply it by both sides by x. So that means xy is equal to x cube plus b, and then we take a particular value for xy, that's a small xy is changed to capital Y. Okay, and that small x cube is here capital X. Okay, then here it is written here, that is xy is equal to y and x cube is equal to capital X, small xy is equal to capital Y. Okay, so in this situation, what the normal equations are? Normal equations are according to this y is equal to x plus b, and now we see that is converted to a straight line where the variables are capital X and capital Y. Okay, so for this, what's the normal equations are? The normal equations are summation of y is equal to a into summation of x plus nb. What's the n here? Particularly for this question, this is 4, because 1, 2, 3, 4, 4 values of x and y are given here. Okay, so y, that is m is 4. Okay, so in normal equations, uh, first normal equation is this, and the second normal equation is summation of xy is equal to a into sigma x square plus b into summation of x. Okay, so how we get the second normal equation? By multiplying x in first normal equations. Okay, and we have discussed the things in descriptive mode in previous video. Okay, so you can see there for how can we find the normal equations of a given distribution of a given particular curve. Okay, so then these are the values, then we find it. So what are these values? So there is capital X, that means the x cube is small, and that's the capital X square, capital Y, capital XY. What we have to find here in these columns is that's are expressed in normal equations. Okay, so what's are in normal equations? Capital Y, capital X, capital XY, capital X square, capital X. So that's why we find these columns. Okay, and then in these columns we find these all values, because we have already X and Y, it is given in this. Okay, here, so X and Y, it is given, we substitute these values in there. Okay, in these columns. Okay, x x to the power 6, x cube, x to the power 6, xy, x to the power 4 into y, and then we find these values. Okay, so these values are summation of capital X is equal to this summation of x square, summation of y, summation of xy. Okay, and then we substitute the values in these normal equations. Okay, and then what we are seeing here, there are two variables a and b in this normal equations, because other than a and b, all are known by this column. Okay, and then we substitute these values, and then we get these two equations. What are these equations? These are just two equations, first and second, and then we solve it, and then we find a is equal to 0.51 and b is equal to minus 2.06. This solution is easy, solving 1 and 2. Okay, then we substitute the values of a and b in this, the equation of a straight line, that in the form of this. Okay, so y is equal to ax plus b. This is the equation of a straight line, that is we have, that is we find that we found here. Okay, so that is, hence the curve of best fit is y is equal to 0.51x minus 2.06. Okay, by substituting the values of a and b here. Okay, so then we finally substitute the values of capital Y and capital X. Okay, so what are these? These are capital Y is equal to small xy, and capital X is equal to x cube. Okay, so these are the values. So then we substitute, then we simplify it, and then we find y is equal to 0.51 x square minus 2.06 by dividing throughout x. Okay, because this is the required format which we have to obtain. Okay, because in this question, that was the format. See here, so y is equal to x square plus b by x. This is the format in which we have to fit a curve to this given distribution. Okay, so why this is, and that's the answer is. Okay, for this question. So you have seen here that how we can fit a curve other than straight line and parabola for a particular distribution. Similarly, there is the possibility that you may be asked to find the of equation for a given distribution in the format of this. See here, first condition is y is equal to x plus b by x. This is neither the equation of straight line and nor the parabola and etc. But similarly, you can find by observing the previous method. Okay, so similarly, we multiply here by x throughout, and then we get capital Y is equal to a capital X plus b. Here we substitute capital Y for xy and capital X for x square. Okay, then we get the equation in simple format. That's the equation of straight line. Similarly, for the second case, that is the y is equal to ax to the power b. So in this case, we take logarithm on both sides. And what's this? So this is log of y to the base 10. Actually, we check the logarithm on both sides on the base 10. Okay. So then we apply the property of logarithm. So that is log a plus log x to the power b. So that is log y is equal to log a plus b log x to the base 10 always. Okay. And then we substitute the values. Log y to the base 10 is equal to capital Y, and log a to the base 10 is equal to capital A. That's constant, another constant. And log x to the base 10 is equal to capital X. Okay. By substituting this, then we get the another equation of straight line. Okay. And then we find as well as the as same as the previous example. Okay. So we can solve it by this method. Okay. And similarly, you can find the different equations to fit here for a given for this given distribution. Okay. Similarly, you can find. Okay. And here the need of the logarithmic table, and by the use of logarithmic table, you can do this type of examples here. And similarly, you can do another type of general curves also. That means you can obtain the general curves also for a particular data. Okay. In next class, in next video, we will do some more concepts of mathematics. Okay.